Okay, so we've defined a couple of threats in wireless networks. Now we look at ways of securing our networks against those threats. 12.7, securing wireless local area networks. All right, we have what we call SSID cloaking, MAC address filtering, to address the threats of keeping wireless intruders out and protecting data. Two early security features were used, still available. We have SSID cloaking, where the APs and routers allow the SSID beacon frame to be disabled. MAC address filtering, an administrator can permit or deny clients access based on their physical MAC address. Okay, so we have those two ways which can be used to address the threats of intruders. SSID cloaking. Remember, we talked of active and passive mode, where in active, the SSID is being broadcasted. In passive, it's not being broadcasted. So the passive one is the same one as the SSID cloaking. The name of the network is not being broadcasted. Therefore, a client needs to know the name of the SSID network to get access to the network. The other side, you have the SSID being broadcasted. The moment, for example, Wi-Fi on, you see all the names of those Wi-Fis, you know, Wi-Fi yakati. So one way of reducing my threats from intruders is not broadcasting that name. If that name is not broadcasted, then an intruder does not know. MAC address filtering. So in this one, this is just another measure which controls access based on the MAC addresses. So we have sort of a white list and a black list, which is created. The white list, it has MAC addresses that are allowed to access the network. The black list, we have MAC addresses that are not allowed to access the network. So even if we all can see the Kutipane network repo, even if probably you are connected to the network, if MAC address yako is blacklisted, you won't get access to the network. I've seen this with if you go to your Wi-Fi hotspot, I think you can do everything. MAC addressing, filtering, you go to hotspot, you can do that. SSID cloaking, you go to your phone, not the access point, access points or my controllers. You go to your phone, you can have SSID cloaking, you can have MAC address filtering. Original authentication methods. The best way to secure a network is to use authentication and encryption systems. And the two types of authentication were introduced with the original 802.11 standard: open system authentication, shared key authentication. All right. So the methods that we described before, SSID cloaking, MAC address filtering, they are okay, but they are not enough. In this area, ukaisa SSID clocking, unovharira inini munhu asingazivi kupenetrate manetworks. But vanoziva, clocking does not work. So the best way to secure your network is to have authentication and encryption systems. With authentication, two types that we have: the open system, the shared key authentication. Open system, basically, that's an open network. All right? No passwords required, used for free internet access. If a client needs to have security to their traffic, then they can potentially use VPN. Hakuna chinonzi free Wi-Fi. I think munomuzimu iriko free Wi-Fi. We don't have data ratinoda secure that much. But kana une data chairo rinofanira secure, une mari. Hakuna chinonzi free Wi-Fi. Because intruders anenge vakamirira. The moment you're not connected to free Wi-Fi, they intercept data, and you know what happens. So to secure that data, you can get access to the public network and you use VPN. That's the open system authentication. Shared key authentication provides mechanisms such as WEP, WPA, PA2, WPA3 to authenticate and encrypt data between the client and the access point. However, the password must be pre-shared between both parties. So this is another way of authentication where there is a password. Ukashare hotspot yako, ukaisa password, ukaenda paunoisa password, create a hotspot, you will see something like this. Security, you can try it. I'm sure you choose WPA2 personal, then oisa kuti password yangu ndoda kuti iite chii. If someone requests kuti ndikuda Wi-Fi, ndikuda ndishare hotspot, you have to give them your password. They know the SSID, probably you're broadcasting it. You now have to give them your password so that they get access. Ndoeno is pre-shared. That's the pre-shared key. So the password must be pre-shared between both parties to connect. If you don't know the password, you won't get access to the network. So that is another way of authenticating network yedu. Right. Shared key authentication methods. There are currently 4 shared key authentication techniques available: wired equivalent privacy, Wi-Fi protected access 2, and protected access 3. With the first one, WEP, this is the original specification designed to secure the data using the RC4 encryption method. WEP is no longer recommended and should never be used. Vanoziva kuplaya mamen in the middle, vanoziva kuattack network, they got over this one. So it should never be used. Very easy. So this one is the OG, and it uses what we call the RC4 encryption with a static key. WPA, this is sort of an improvement after WEP. The only difference, we now have what we call the temporal key integrity protocol, TKIP. So WPA is basically WEP plus TKIP. The same things that were with WEP, but now we have an additional TKIP encryption algorithm that is being used. The version 2, another improvement. Instead of using the TKIP, the version 2 is basically the version 1 plus the AES encryption protocol. The encryption protocol, as we go from 1, 2, 3, the encryption protocols improves. So you cannot easily read the information which is being sent over the network. So WPA2, WPA plus the advanced encryption standard. With WPA3, this is the next generation Wi-Fi security. All enabled devices use the latest security methods, disallow outdated legacy protocols, require the use of protected management frames. This one, personally, not familiar with that one. I know of these ones. This one, WPA2, currently, most technologies that we are using WPA2. Obviously, WPA3 is an improvement of WPA2. Not so sure how improved it is. I've never encountered WPA3 devices, so I don't have much knowledge of that. But WPA2 will get through that in a moment. Authenticating home users. Right. Home routers typically have 2 choices. WPA, we don't use WPA. We now use WPA2. And WPA2 has 2 authentication methods, personal and enterprise. With personal, this is intended for home users and small offices and uses a pre-shared key. So with personal, we have a pre-shared key. That's the thing with personal. ndoiri pamafoni edu WPA2 PSK personal. Ukashare Wi-Fi yako, the security yaunoisa ndiyo PA2 WPA2 PSK. Pre-shared key. Unoudza munhu kuti password ichi, then a client gets access to your network that way. Pre-shared key. Now with enterprise, in large organizations, this one is no longer safe to use pre-shared keys in large organizations. We have WPA2 enterprise intended for enterprise networks, and it requires a remote authentication dial-in user service radius authentication server. The server must be authenticated by the radius server. The device must be authenticated by the radius server, and then users must authenticate using the 802.1x standard, 802.1x standard, which uses EAP, Extensible Authentication Protocol. Basically, the difference between these two, personal and enterprise, this one, it has a radius server. Right? If I have an access point, let's have a client, let's have an access point, let's have a server. Right? With the pre-shared key, WPA2 personal, PSK, there is just communication between these two. The client has to know what is the password, what is the pre-shared key. Therefore, it gets access to the access point. Communication only between the client and the access point. If you want, with the controller, with the help of the controller as well. But in enterprises, there is need of having a server. Let me see. Okay, there is need of having a server. Now, instead of having a client access point only, we now have a server. The explanation of this WPA enterprise is very important. I think I need to explain this one a little bit more. So let me create another. It will be very important understanding these things when we do the configurations. At the moment, we are just introducing the concepts. Understanding the concepts helps you. Configurations. If you don't get it, it's very difficult now to understand it. How do I configure whatever I'm configuring? So we have a user or a client, we have an access point, we have a server right here. Right? One, the user requests authentication. It does not have a pre-shared key, haina password hainayo. It requests authentication from the access point. Two, the access point initiates authentication with the server. Three, server verifies the credentials of the user. So before this whole process yatanga, user anenge ane username nepassword yake yanenge akacreaterwa with the organization. So ndo yaanoita log into the network or request authentication. Authentication ikadeniwa, it means these two things are wrong. Therefore, the user will not get access to the network. So the user requests authentication, access point initiates authentication, server responds. Then lastly, server responds out user uitomuziva, username inotoiziva. Then we have four, the user getting access to the network. So it's a bit of a process. It's more secure than just using a pre-shared key. Here we have a server. It's a bit of a process. So you see, when we do my configurations, they'll create my user netika. Configurations, they'll create a server redu rikushanda as our radius server each, and how is it connected to the access point. And that is enterprise for you. Using a server. With pre-shared key, we only have, with WPA2 personal, we only have a, how do I remove this? we only have a PSK, a pre-shared key. Right, so this is as far as we can go with our authentication methods. Right, I think it's also important to introduce with this one, with enterprise. We have what we call AAA. I've seen a lot of questions asking about AAA. Authentication, authorization, accounting. So with enterprise, it addresses these three things. Authentication, who are you? Who is the user with authentication, right? Who has access? Authentication. Accounting, let me put it this way before I get confused. Authentication, very important to understand AAA. Accounting, the third one, authorization. Authorization. So this is one. First, you authenticate, you're authorized, then you're accounted. So with authentication, who has access to the network? Who has access? Then authorization, what do they have access to? You might have access to the network, but you don't have access to everything. You are limited. So that is authorization. Then accounting, who has accessed something? So the AAA accounts for Diana and access, Diana it access yacho. And what do they get access to? And all of these are because of this radius server. Very important, AAA. Encryption methods. After authentication, we have encryption. And the two main methods that are used for encryption in WPA and WPA2. I already said we don't use this one. We have TKIP and AES. We won't get deep into these encryption methods, but basically TKIP is used by WPA2 and it provides support for legacy wireless LAN. WPA and its support for legacy wireless LAN equipment makes use of WEP but encrypts the layer 2 payload using TKIP. We have AES used by WPA2, which uses counter, cipher, mode with blockchain, CCMP with blockchain message authentication protocol. These are encryption protocols that they use that allows destination hosts to recognize if the encrypted and non-encrypted bits have been altered. Right, if we get into these encryption protocols, we can spend another hour here. But I think it's good enough to know at this point, we have two encryption protocols that are used. WPA, it uses TKIP, and AES is used by WPA2. WPA2, that's good enough. The protocol which is being used, WPA, we no longer use this one though. We won't even configure that one, WPA. We'll only be configuring using WPA2. All right, let's finish up. 46, authentication in enterprise. Enterprise security mode choice requires AAA radius server. 3 pieces of information are required: the radius server IP address, the UDP ports, port numbers, the shared key. Right, when we are configuring, I've already explained enterprise, how does it work? How does the client associate, get authenticated with the AP, and how does the AP communicate with the server to initiate processing authentication and to give access to the client? I've already explained that. Now, here we have 3 pieces of information that is required, especially when configure. You need the server IP address. You need to know my ports, understand this one, and we have 1812, 1813. When we actually do the configuring, I think it will be much easier to verify these ports. Shared key, we do have a shared key here. but it is only used to authenticate the access point and the radius server. Authentication a client in a network inoshandisa username, will get there. A client anenge ane username nepassword yake. So if a client has a username, therefore this leads to nyaya yekuziva paaccounting apo kuziva kuti aita access ndiani. Very important. Because of having a username nepassword, it's different from just having a pre-shared key. It's difficult to know kuti aita access to the network ndiani because the password share to everyone. Wangopa munhu wese password. Munhu just gets access to the network oita zvaarida kuita. With this one though, we actually know who gets access because they have a username and a password created for them. WPA3, because WPA2 is no longer considered secure. This is square arrow. WPA2 is no longer considered secure. WPA3 is recommended when available. Its features include personal, enterprise, open networks, IoT onboarding. Personal, it thwarts brute force attacks using SAE. I'm not sure if that's a protocol. Enterprise uses ETO 2.1 authentication. Okay, this one we also use it with WPA2. However, it requires the use of 192-bit cryptographic suite and eliminates the mixing of security protocols from previous standards. So WPA3, for now, I'll just put a question mark here. But I know of IoT boarding. For guys who are doing telecommunications, you probably deal with a lot of IoT devices. A brief background. IoT device yako haina graphical user interface, haina probably CLI as well. How does it get access to the internet, to your Wi-Fi, to your wireless network? How does an IoT device get access to the wireless network? We have process known as IoT onboarding. Phone yako kana uchinaenda pa Wi-Fi, user interface, unaenda unaisa password. Ma-access points yedu tine user interface or command line. Tunoenda unoisa password, toisa ma-username. But my devices mamwe haana all those things. So we have IoT onboarding. I think that's the only part here WPA3 I understand. So with IoT onboarding, you have a QR code. A device getting a QR code, and that QR code is used to get access to the internet. And it uses what we call device provisioning protocol to quickly onboard IoT devices. So WPA3, like I said, question mark. As we do our configurations, you see security we'll be using is WPA2, personal. We do my configurations for personal and enterprise. And basically that's it for wireless concepts. Now, preparing ourselves for the configurations, very important to understand. Let's go through this. If you don't understand the concepts first, it will be very difficult to do the configurations. Right, you need to understand, let's see, our starting point right here, the standards. If the standards don't match standard iripa client, the standard kushandiswa access point, or the standard kushandiswa controller, if they are not the same and they are not compatible, you won't get access to the network. The wireless network will not work. That's one. Let's see. Radio frequencies here as well. If client is using this band and access point is using this band, compatibility issues, network won't work. So you need to make sure all those things match from the standards and the frequency bands which are being used. They need to match. All right, wireless components, our adapters, we won't configure that. All right, so we'll be configuring our wireless routers as already seen Router redu, it has three functionalities, which can be three separate devices, but it's sort of three separate functionalities in one device. So wireless router will be configured as an access point. We get access to it via the graphical user interface, or we have an admin and we get access to the wireless router. We configure it as an access point. We also configure it as a switch as well as a router. So you see most home networks, you have modem, then you have your wireless router here. Then wireless router gets you wired network to client one. Then you can have probably wireless to client two. This is the setup that we are going to be configuring. We have our modem here. This is where the internet is, right? Our modem gives access to the internet to our wireless router. Then we configure our wireless router to offer wireless network to our client as well as wired to our client as well. That's the wireless router. Those are the configurations we are going to do for wireless router. My access points, they just offer wireless access. The in between the wireless access and the wired network to name access point. So if I go here, instead of having a client here, I can have an access point. So ndaisa wireless router yangu, ndinoda extend the coverage. I have an access point on the wired network. Then I have wireless access here. So we can have another client one, client two, client three. So these are the connections and configurations that chaita when we actually do our configurations, right? Access points, configurations. We're going to configure the AAP. In this example, AAP read in total autonomous here because upon controller, we only have the wireless router. In another case, we are going to have a controller WAC. We are going to have a number of access points, and all of them, they are connected to the wired network. And we are going to configure the wireless LAN controller. Kuiudza kuti access points ari munetwork ndeapi, anofanira kupiwa maadresses api. Quite a number of things we are going to do. We are going to configure my access points yedu kuti broadcast the network yedu. Then we are going to have my clients connecting to the network. Those are the configurations that we are going to do. Let me see. Wireless antennas, we are not going to touch on antennas. Frame structure, association. Okay. Passive, not important. K-pop. Here is very important. We are also going to configure network here to use that protocol, control and provisioning protocol. So it's very important to understand that as a protocol, no function as say. A tunnel is created between the access point and the wireless LAN controller. How is that tunnel created? My configurations are not with any tunnel or pafano information. The app, very important as well. We'll get there. Flex Connect. We're also going to configure Flex Connect on our access points or our controllers so that access points can communicate with the controller over the internet or over a one link. So it's another configuration we are going to do. Very important to understand as well. When we talk of Flex Connect, what are we talking of? We did that in the last session. Channel management, planning. When we do our planning, channel management is very important. Understanding to ukaisa access point placement is improper planning, then you are going to have interference. That is channel management. You're going to have interference. So it all starts with understanding with the channel chi. Which channels am I going to use so that I don't get interference? Very important to understand the issues to do with channels. 1611 channels that I can use without having interference, even if they are overlapping. Wireless LAN deployment, Security. Tosika pa security. It's very important to understand how an intruder can attack the network. That way you know how to secure the network. It's very important to know how an employee can configure incorrectly network or can play around with the network as series and a couple of changes can lead to, for example, DOS attack. If you understand how that happens, it becomes easier to know how to deal with it. So understanding my attacks is very important. After that, you then understand how to deal with those attacks. Men in the mid do securing wireless LANs, clocking. We're not going to touch on those two, MAC address filtering, no. Right. Authentication methods, we're going to configure WPA2 mostly. Personal, we're going to deal with this one, WPA2, personal and enterprise. So we are going to demonstrate the difference between the two. One, you only have a PSK appreciate key. The other one, there is a server. There's no ISQA. Server ISQA, it means you need to know address your server yoyo inofanira configure. Wireless controller rinofanira kuudzwa kunzi server rauri kushandisa nderepi, or access point rinofanira kuudzwa kunzi server rauri kushandisa for authentication nderepi. Those are some of the configurations that we are going to be going through. Then I think basically that's it. So next lesson, next session that we do, we actually start the configurations and we'll see how it goes. So that's it for wireless LAN concepts. Thank you very much for giving an ear.